About every 2 seconds, someone in the United States needs blood. That's a lot of blood to transfuse from donors to patients. But how on earth did we develop this procedure? Hey guys, Amy with you on D News today. Now, the faults and failures of early transfusions have significantly helped shape how blood transfusion procedures work today. Long before anyone really understood blood, scientists knew that blood was a life force flowing through us all. To harness the power of blood and infuse it into another person, usually someone sick or dying, patients would usually drink the blood, which of course had no effect. The idea of a blood transfusion didn't properly occur until William Harvey's 1628 discovery that blood circulates through the body in one direction. It was then that scholars and doctors realized that transfusions were a possible method of rejuvenating the sick. By the end of the 17th century, physicians were using quills as needles and silver pipes to transfer blood from a donor to a recipient, but the donor was usually an animal. And what no one knew at the time was that animal blood cells are incompatible with human blood. It wasn't until obstetrician James Blundell started using human blood to replace blood lost in childbirth in the early 1800s that transfusions started working. At least they worked some of the time. Physician Karl Landsteiner set out to figure out why some blood transfusion patients lived and others died. This line of inquiry led him to discover the ABO blood type groups in 1901. It was Landsteiner's groundbreaking work that helped classify blood into one of 4 categories: A, B, AB, and O. These are defined by the antigens and antibodies on the cells. People with type A blood, for example, have the A antigen on the surface of their red cells, and their bodies won't produce the anti-A antibodies. So if any type A blood is introduced into that person's body, it won't recognize the new cells as foreign and won't attack them. But if type B blood is injected into a type A blood person, the anti-B antibodies on the donated blood will be seen as foreign. The host body will reject the transfusion. Another factor for rejection comes down to a protein on the surface of red blood cells called the rhesus or Rh factor. Blood cells either possess the protein, meaning that you are Rh positive, or they don't, meaning that you are negative. These factors combine to make 8 blood types. Now, all of this is important because your blood type determines your compatibility with a donor. The red blood cells of people with type O blood have A or B antigens on their surface, making them a universal donor. People with type AB blood don't produce any antibodies, so they are universal recipients. But everyone else is only compatible with their specific type. So knowing what we've learned over centuries of trial and error, blood transfusions have become simpler. There's no need for a living donor. Instead, donated red blood cells can be stored for as long as 42 days, meaning a patient in need is simply given an IV and a bag of blood to replenish what they're missing or restore blood lost in an accident. There's so much to blood, more than we can get into on a single episode. Luckily, Trace did a deep dive into blood on his podcast show. Check it out. There's loads of creepy cool stuff to learn about.
Each red blood cell contains millions of self-antigens. Our body knows about them, they know they're harmless, they don't do anything. The antigens is what give you your blood type.
So with so many blood transfusions needed, how many of you guys out there have donated? Let us know in the comments, be sure to like this video, and of course subscribe so you never miss a new episode of D News.